LM. AFLD.
AFLD.
Please proceed, LWO.
You should be looking at your satellite image. Really barely any clouds, nothing of concern. Nothing on radar, not expecting any precipitation. Our wind speeds have really maxed out at peaks to 22 knot over the past 4 hours and expected to remain so. Our wind direction is from 100. We're going all LCCs and expected to remain so through the count. Our T0 forecast winds 20 knots sustained with peak to 25 knots, less than 10% POV for ground winds. Temperatures 68 degrees Fahrenheit and expected to remain so through the count. Solar weather is at normal background levels and expected to remain so through the count. This concludes the weather brief.
And there you heard it. That was Jessica Williams, the launch weather officer with the 45th Space Wing, giving a great report. You heard her mention the 10% concern about ground winds. She also mentioned there was a 22-knot wind that they've observed sustained. That can have an impact on the rocket. We'll get to that in a second, but there's your forecast up on your screen now. You can see those winds, as she mentioned, 20 knots. Observed at 22 knots just a few moments ago. The temperature 68 degrees and only a 10% violation. But, Mick, those winds could be a factor.
Yes, absolutely. The launch team's looking at those. The ground winds here at Slick 41. They want to make sure they're under a certain level before we get ready to go tonight to make sure the vehicle is in good shape and environments on all components are good. So really happy to hear a less than 10% POV tonight. I'm happy with that weather forecast.
Great news moving forward in the count. We want to go back in time just a little bit to show you how the rocket got to the pad here. There it is, the Atlas V in its vertical integration facility, not far from the pad, but this is the day it moved out. It was Saturday. Mick, you and I were there, standing just alongside the path there as the Atlas V 190-foot tall rocket went right by us.
58 meters.
58 meters.
58 meters for our European friends.
Mick has been doing our calculations to metric all evening, and in fact, that's actually been an important part of the collaboration with international partners.
Absolutely.
Who use the metric system. But when that rocket went by, Mick, that was an impressive sight to see it get out to the pad.
Oh, yeah, Gerald, I had a great time with you on the NASA Edge show, rollout show yesterday. It was great to see the Atlas V head to the pad and get ready for Solar Orbiter launch tonight. It was a beautiful day for a rollout yesterday and exciting to watch that 411 go there. So
it sure was. And we'll find out more about this rocket and its unique configuration in just a bit. But there you can see it on the pad. Everything is looking good. We will continue to monitor the communication channels between the launch teams. But for now, Joshua, we're going to send it back to you in the ASOC.
Thanks, Daryl and Nick. Appreciate that. We want to bring you another update, actually, that came to us this afternoon. For those that are space enthusiasts, you will know that we had planned to launch Antares rocket, but Northrop Grumman scrubbed tonight's Antares launch after off-nominal readings from a ground support sensor. Northrop Grumman and NASA have set the next launch attempt to no earlier than February 13th at 4:06 p.m. Eastern Time due to an unfavorable weather forecast over the next 2 days, time required to address the ground support issue, and time required to update the late load science. So be sure to tune in just a few days. We are actually going to send you over now to understand more about the incredible international collaboration that's happening between ESA and NASA. NASA's Laura Aguiar is live with members of both agencies' leadership teams to find out more.
Thank you, Joshua. I am joined by Dr. Thomas Zurbuchen, who heads up NASA's Science Mission Directorate, and Professor Gunter Hasinger, who's with the European Space Agency, his Director of Science. So, gentlemen, tell us more about the collaboration.
Okay. Both agencies have an impressive suite of missions out there in the solar system and for astrophysics. But many of these missions are done in international collaboration. And when we think about the Sun, there have been two missions, Ulysses, SOHO, which we have already done 25 years ago in strong partnership. And the Solar Orbiter is just a beautiful example of international collaboration.
At NASA, 2/3 of our missions are done in international collaboration, so we're really much used to it. And what happens is the science community works together as one. And so when we work together, it's a very natural, locking of arms. It's not easy because we have different cultures, we do things differently, and so we learn to trust each other and go forward. So this one is a really unique collaboration, and with the spacecraft and most instruments are done in Europe, a couple sensor heads, one full instrument done here in the US, and of course, we're so excited to launch it here in the United States.
And Gunter, Solar Orbiter is going to study the sun. Now, why is that important to the agency's overall space exploration plans?
So, you know, the sun is what gives us life and supports us, but it also poses dangers. It is governed by a strong, unknown hidden force, the magnetic field. The magnetic field can actually create explosions that create magnetic storms that can affect the satellites out there, that can affect the life of astronauts. And so to understand the sun is actually of vital importance for all of us, and therefore also for the space agencies.
So we're going to learn a lot. Now, Thomas, you had an early touch on this project. Can you tell us a little bit about that?
Yeah, it's of all the missions that we're working with here, over 100 in NASA Science Mission Directorate, this is the one that I used to work on when I was a lot younger. I was, over a dozen years ago, I was part of the Science and Technology Definition Team, an international team that came up with the overall design of this, and actually was part of the mission team too, because I, together with the team, came up with a sensor that is now sitting on top of this rocket. How exciting is that,
you're
right?
Super excited.
Yeah.
Well, Joshua, the collaborators have gotten Solar Orbiter ready, so let's get to launch.
Yeah, absolutely. We're all excited for that. We're now just about 23 minutes away from our planned liftoff at 11:03 p.m. Eastern Time. And we're going to head out now to the Kennedy Space Center press site, where NASA Edge's Blair Allen has more on NASA's heliophysics efforts. Blair?
Thanks so much, Joshua. Joining us now is Nikki Fox. And Nikki, I'm so glad to have you on the show. As you know, NASA Edge, we're big fans of heliophysics. And as we just heard, it's very important as we work on these partnerships, work with our international partners to study the sun. I'm wondering, from a solar orbiter standpoint, how can both agencies benefit scientifically with this mission?
Well, it's a wonderful partnership. I mean, obviously, I come from Europe, and so I'm particularly happy to see an ESA-NASA partnership.
Absolutely.
The ESA-led mission, NASA launching, it is just a wonderful time, and we cannot wait to welcome Solar Orbiter up into the fleet. Particularly, I'm excited, of course, because of the wonderful partnership between Parker Solar Probe and Solar Orbiter, and just really so much more science that we can achieve with these two missions. Parker exploring a region we've never been to before, Solar Orbiter imaging for the very first time the poles of a star, and that is incredible.
That's right, and it's incredible. And I was just thinking that there's that crossover side where they actually will look at the same area at one point. Talk a little bit about that.
There are actually many times that we'll look at the same area, and to be honest, they are doing great science. You know, sometimes we're not in the same line, but we're in quadrature. And so we're looking at different areas of the sun, and that's just as exciting. The beginning of the Solar Orbiter mission, she will still be in the ecliptic plane. So she'll be in that sort of around the sun's equator where all the planets are orbiting. So is Parker Solar Probe. And so we have so many conjunctions that are interesting magnetically, radially. It's fabulous. And then as she moves out of the ecliptic, the science changes. But yes, Solar Orbiter giving wonderful views, Parker Solar Probe flying right through that field of view. It's just fabulous.
I tell you what, my mind is blown. I know we're going to get a lot of science, but right now we got to send it back to our friend Joshua, who's at the ASOC. Joshua, let us know what's going on.
Hey, thanks, Blair. We'll catch up with you more after liftoff today. The work of Solar Orbiter is a pioneering effort, but it's not the first time that we've sent robotic explorers to take a closer look at the sun.
3, 2, 1, 0. Liftoff of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe.
You may remember that NASA launched Parker Solar Probe on its journey to touch the sun, so to speak, seen here in the early morning hours, August 12, 2018. The Solar Orbiter and Parker Solar Probe missions are complementary, focused on studying different elements of the sun. They'll be sharing data, building a larger context with which to understand our star. Just as with Parker, the Solar Orbiter mission there we see poised to fly tonight has been managed by NASA's Launch Services Program, or LSP, based here at the Kennedy Space Center. For more than 2 decades, LSP has been hard at work supporting a global scientific community by ensuring missions successfully get off the ground and on their way to the correct celestial destination. Whether that be close to home for Earth-ocean observation, destined for the sun to capture debut images of its poles, or a cutting-edge rover and helicopter to further explore Mars. And that's just the year 2020. Let's take a closer look at this year's flight manifest. Lots of great science ahead for LSP this year, kicking off tonight with this launch. Daryl and Mick, over to you for a launch countdown update.
Yeah, that's right, Joshua. We just entered a few moments ago the planned 4-minute hold. This is a 15-minute period of time, Mick,
yes,
where they hold up everything and make some evaluations at this point in time.
That's correct. The team will use this 15 minutes to take a last look at all their systems, make sure everything's good, make sure everything's ready to go, verify they've all their red line limits and operational limits, and that they're ready to proceed with the count. So this is their last time to do that while we're in this hold, and so far we're not working any issues, and things are going well. And Chief Engineer for NASA's Launch Services Program, Dave Solberger, polled his team, and they're ready to enter the terminal count after getting out of this hold. So things are looking good.
A very smooth count up until this point, and as you look at the camera views that we're showing you, you can see that condensation coming off the rocket as the wind blows by. In fact, the middle portion of the rocket is white. It was tan before. Just where it lines up with the U, L, and A, that is all ice covering that portion of the rocket, which has been chilled down to minus 300 degrees Fahrenheit.
Minus 184 degrees Celsius, roughly.
That's right. Mick's got his little professor calculator here, and he's doing on-the-fly metric calculations. Appreciate that. Hey, you know, this is an interesting rocket because it is configured in a very unique way. Tell us a little bit more about that, Mick.
Yeah, the Atlas V 411 vehicle we're flying this evening is a unique configuration in the fact that it has one solid rocket booster on the vehicle. That's a unique configuration for ULA and this vehicle. This configuration has flown 5 times, including NASA's OSIRIS-REx mission. So tonight will be the 6th mission. Our first stage, or our booster, is powered by RD-180 engine. This engine burns RP-1 and liquid oxygen as it's fueled, or RP-1 is a highly purified kerosene. So that helps deliver the thrust we need, and delivering that thrust tonight of about 860,000 pounds or 1.2 million pounds with the solid rocket booster. That's 5.2 million newtons, just in case you're wondering.
Thank you.
But we do move on up the stage to the second stage, which is Centaur, using an RL-10A engine. This will be the last single RL-10A flown on this configuration. From here on out, they'll use 2 engines to fly on an Atlas vehicle, so we're very proud of that this evening. The RL-10 engine is a cryogenic engine, so it uses liquid oxygen and liquid hydrogen as its fuel in the upper stage, producing about 22,000 pounds of thrust, or 99.2 kilonewtons.
I was hoping you had that metric conversion. Did well.
Unique configuration that we're happy to fly tonight.
All right, very good. Thank you, Mick. And, you know, to this point, the count has gone very smooth. We've heard nothing but good reports. So we'll turn it back over to Joshua in the studio, and we'll continue to monitor the count here. Joshua?
Thank you, gentlemen. Appreciate that. Look forward to hearing more from you soon. Hopefully still lots of good news ahead. Let's take a look at what to expect going forward. Obviously, that rocket is poised on the pad, but here's what's going to happen after launch through spacecraft separation.
And liftoff of the United Launch Alliance Atlas V rocket.
The Atlas V RD-180 main engine and 1 solid rocket booster ignite to generate more than 5.3 million newtons of thrust to lift the rocket on its way towards a hyperbolic escape trajectory. Shortly after liftoff, Atlas begins a pitchover to attain the proper flight path while minimizing the dynamic pressure the vehicle experiences during flight. The Atlas V reaches Mach 1, the speed of sound, at 58 seconds. The single SRB is jettisoned at 2 minutes 20 seconds. At 4 minutes 3 seconds, the propellant levels deplete and the booster engine shuts down. 6 seconds later, the Atlas Centaur separation system activates to release the booster stage. The vehicle now weighs less than 14% of what it did at liftoff. 10 seconds later, the first burn of the Centaur main engine begins. This burn guides the Centaur into a near circular parking orbit. Approaching payload fairing jettison, the Centaur is burning propellant at a rate of 23 kilograms per second, traveling at more than 17,700 kilometers per hour, and located nearly 134 kilometers in altitude and 470 kilometers downrange. At 4 minutes 27 seconds, the payload fairing is jettisoned. The vehicle now weighs less than 7% of what it did at liftoff, 4.5 minutes earlier. 12 minutes 14 seconds into flight, cutoff of the Centaur main engine, or MECO-1, occurs. The mission now enters a coast phase in preparation for the second burn. Because this targeted Earth escape trajectory varies from day to day, the coast and the second burn will vary to accommodate this. The Centaur main engine is restarted at 42 minutes 58 seconds for the second and final engine burn. Nearly 7 minutes later, final cutoff of the Centaur main engine occurs. At 52 minutes 40 seconds, Centaur releases Solar Orbiter for the European Space Agency and NASA to begin its nearly 2-year journey to the Sun. After using gravity assist maneuvers at Earth and Venus, Solar Orbiter will help us understand how our star creates and controls the heliosphere, a giant bubble of charged particles blown by the solar wind that permeates the whole solar system and influences the planets within it.
For those of you just joining us, welcome to team coverage of the launch of the Solar Orbiter mission, destined for unprecedented views of the poles of our star, the Sun. We're now just about 12 and a half minutes away from launch. Here are a few things that you need to know about this groundbreaking mission. The Atlas V rocket for this mission is in a 4-1-1 configuration, sending Solar Orbiter to a high-latitude orbit, enabling the first ever images of the Sun's poles. This single launch will deliver 10 state-of-the-art instruments to study our star. Gravity-assist flybys of both Venus and Earth will enable the highly elliptical orbit. After liftoff, it will take just under 2 years to reach its operational orbit for a 7-year planned mission. We do have a 2-hour launch window tonight, but launch is still on track for liftoff at 11:03 p.m. Eastern Time from Space Launch Complex 41 at the Cape Canaveral Air Force Station. There you see on screen. Solar Orbiter will take off on a United Launch Alliance Atlas V rocket. Again, they're poised and nearly fueled, ready for flight. This is an international collaborative mission between the European Space Agency and NASA. The spacecraft has been developed by Airbus Defence and Space. ESA's Engineering and Test Center in the Netherlands is managing the development effort. And the European Space Operations Center in Germany will operate Solar Orbiter after launch. Solar Orbiter's flight will take it to roughly 26 million miles from the Sun, or about 42 million kilometers. That's just over 1/4 of the distance from the Sun to the Earth. It will experience sunlight 13 times more intense than we feel here on Earth, and to survive, it is equipped with a heat shield capable of withstanding temperatures over 900 degrees Fahrenheit, or about 500 degrees Celsius. The science to be conducted will range from analyzing solar winds and solar magnetic fields to remote sensing and high-resolution imaging of the Sun's atmosphere, the corona, and even solar disks. One phenomenon to be explored is that the Sun goes through an 11-year cycle that involves emerging and vanishing sunspots, as well as a flipping of its entire magnetic field. Why does all of this happen? Well, we're hoping Solar Orbiter will shed some light on that. The mission intends to answer some fundamental cause and effect questions like how do flares and coronal mass ejections impact our solar system, and how do the energetic particles originate that lead to extreme space weather? The answers to these questions can not only have a direct impact on our daily life and the electronics you rely on, but also impact future exploration as we pioneer to the Moon, Mars, and beyond. Let's head back now over to Daryl and Mick to take us through the rest of the count. Gentlemen, count us down.
Thank you very much, Joshua. We look forward to getting on with the count in just a few minutes. We are, of course, in a hold at this very moment, T-minus 4 minutes in holding, but we've got a little bit of business to do as we go through here. So far, nothing to report in terms of the count itself and the teams. Everything working pretty smooth to this point, Mick.
Yeah, everything is good. ULA launch conductor Scott Barney is giving his briefing right now to his team of what's going to happen as they get ready to pick up the pole at T-minus 4 and counting. But while we see the teams here in all different places, Darryl, we have them all over the world. What we see on the screen here is the team in the Mission Director Center here at AE, which has our ESA folks up front.
And then just across the way, just a few miles away, is the Atlas Spaceflight Operations Center. That is where the ULA launch team is going through their count. And then, of course, in Denver, we have a team out there as well. The Denver Operations Support Center in Denver, Colorado, where ULA is based. In addition to that, we have a European space operations in Germany.
Absolutely. We have ESA teams supporting, as you heard earlier, from Germany. where they will operate and control the spacecraft after it separates this evening. So big collaboration of teams that have put this mission together and get ready for launch this evening.
And we've had some fun talking about the conversions between standard and metric, but we were talking earlier, Mick, there's actually, that played a role in working with this international collaboration, because much of what our teams here in America do is on standard, and overseas they're on metric. So there was a bit of a conversion that had to go between.
Yeah, absolutely. It's been really fun working with our international partners on this mission, and there have been some challenges with the unit conversions and some communications, but that has been key, is communication between the teams. All of us has been done very well, and as Tim Dunn put it, our launch manager from NASA, at our readiness review last week, we all speak the universal language of mission success, and that's what's gotten us here this evening. So working with our international partners has been fun. We're very excited to see Solar Orbiter get off the Earth tonight and head on its way to the sun to start its science.
And it's going to do some big science once it's there and in orbit. For now, we are looking at a shot of the rocket on the ground as the water vapor condenses around the super cooled liquid oxygen. In just a few seconds, we are going to get a status poll from Launch Director Scott Barney of ULA, and he's going to give that and a final check before we begin to resume the count. Let's listen in now as Scott conducts that poll over at United Launch Alliance.
Status check to proceed with terminal count. Atlas systems. Propulsion. Go. Hydraulic. Go. Pneumatics. Go. LO2. Go. Water. Go. Centaur systems. Propulsion. Go. Pneumatics. Go. LO2. Go. LH2. Go. ASGAS. Go. Electrical systems. Airborne. Go. Ground. Go. Facility. Go. RFFTS. Go. Flight control. Go. GCQ. Go. Operations support. Go. COM. Go. Umbilicals. Go. ECS. Go. Redline monitor. Go. Quality. Rick, go. Op safety manager. Go. ULA safety officer. Go. Vehicle system engineer. Go. Anomaly chief. Go. Range coordinator. Clear to proceed. Launch director. You have permission to launch. Proceeding with the count. ALC, verified T0 is set for 0403 Zulu.
Verified. And so we are on time and on schedule for this launch at 11:03 Eastern time. There, you just got the confirmed count from Scott Barney. That's good news.
Oh, absolutely. I'll tell you, my heart's beating really good. It's awesome to hear the team give a go and everything's clear. That means they've been working all their stuff and everything looks good on the vehicle. Targeting an 11:03 p.m. Eastern time liftoff. I can't tell you how excited I am to hear that poll.
That's right. And now they're configuring the spacecraft to go on to internal power, off of its shore power, its land power. Talk about that.
Yeah, in parallel with the launch team getting the launch vehicle ready, the spacecraft team is preparing the Solar Orbiter satellite to get ready. And we just heard over our nets that the spacecraft is on internal power, configured for launch. Everything looks green and go. So we've heard from the spacecraft and from the launch vehicle that things look really good tonight to get Solar Orbiter off the ground. That's a beautiful thing to hear on the net, that we're moving forward and working no issues.
And now Tim Dunn, NASA's launch director, will begin to look at his team and conduct his portion of the business.
Yes, he'll check in with his NASA chief engineer, Dave Solberger, and LSP Chuck Duvall, and make sure the NASA team is ready to support and proceed forward. So we'll hear how things go.
It's a beautiful evening outside. If you are in the area and ready to watch this rocket launch, it's going to be a beauty. We've got a full moon tonight here in Florida and across the area. And as well, we're going to see this beautiful launch. This spot right here is our Banana Creek viewing area, where you can see we've got several hundred people out there in total, probably about 4,000 across the entire area. Let's count it in to the terminal count, 3, 2, and 1, and we have begun our count and resumed it. We are now 3 minutes and 53 seconds away from liftoff.
That's correct, and we did hear our NASA launch manager, Tim Dunn, say that the NASA team is go. He reported that out to ULA's launch director, Lou Mangieri. And so that's a good call out for us, too, to hear that the vehicle is ready to proceed tonight. And as you said, that was a beautiful sight of the Atlas out there on the pad. And things are looking really well for an 11:03 liftoff this evening.
And this is, you mentioned this earlier about the configuration with that one solid rocket booster on the side. Sometimes people have asked, how does that work with having one booster on the side of the rocket? Doesn't it kind of push the rocket over?
Yeah, it does actually, but I will say we talked about the first stage booster engine, the RD-180. The RD-180 has a lot of control margin left that it can offset that asymmetrical setup of the one solid on the 411 vehicle. The 411 vehicle is a unique configuration that will provide a great ride for Solar Orbiter this evening, as it has done for 5 other missions in this configuration. So yeah, RD-180 takes over and works really well to make sure the vehicle gets off the pad and heads to space where it's supposed to.
2 minutes and 45 seconds until liftoff here as we get down to the final minutes of the count. The launch teams in a flurry of activity right now as they are listening in and talking to their various team members before this launch takes off. It's an exciting moment as we get down now here to the final few minutes. Talk about the teams and the activity that's going on right now.
Yeah, it takes a lot of control between the teams, make sure they're all talking together. They're actually preparing their final preps of getting the tanks to flight pressures, getting all the valves in the right position, making sure avionics is ready to go, and the vehicle is all green as it continues to be topped off, and basically putting that last little bit of fuel into the tanks for Centaur and booster. And things are going well. Vehicle has to go on internal power just prior to liftoff, and so the team is continuing to work all of that as they get ready for liftoff at 11:03.
Very good. And the count now going under 1 minute and 40 seconds. Let's listen in as the activity begins to pick up on the countdown net.
We just heard that FTS was armed, Flight Termination System, which our friends at the United Space Force will follow the launch from this evening.
FTS count started. 115. 110.
Vent valves locked.
Locking the vent valves will bring the booster tank and tanks up to flight pressure, getting everything ready for launch this evening. We just heard from the range officer that the range is green and ready to move forward.
The range is green. That is a big step moving forward. Everything's clear. Basically mean there is no nothing to impede launch, nothing out there in the water, nothing out there in the air. T-minus 30 seconds as we count down to the liftoff of an Atlas V rocket.
25.
Status check. Go Atlas. Go Centaur. Go Solar Orbiter.
There you heard the final status check for booster Centaur and the spacecraft. Everything is go.
And so here we go. T-minus 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And liftoff of our solar orbiter, an international collaboration to give us new images and a better understanding of our life-giving star. Listening now, you hear the voice of Patrick Moore, ULA's launch commentator.
Now 25 seconds into flight. Chamber pressure on the SRB looks good. Engine operating parameters on the RD-180 also look good.
Good report so far. Atlas V beginning to pitch
35 seconds in, vehicle is completing the pitch over maneuver. Now 41 seconds into flight.
45 seconds into flight, everything is looking good.
We heard that the RD-180 engine was operational.
RD-180 throttling down slightly as expected, and engine response looks good.
I'm going to pull those engines down for just a little bit as we anticipate max Q.
Now supersonic. Vehicle's now now passing through max Q, maximum dynamic pressure.
Right, maximum dynamic pressure is the period of maximum mechanical stress on the rocket because it's reached its highest velocity and resistance created by the Earth's atmosphere. Made it through and they're throttling back up.
And standing by for SRB burnout. And we have burnout on the solid rocket booster. Atlas will hold on to the SRB for an additional 47 seconds prior to jettison.
They're going to let that thing go at 2 minutes and 19 seconds.
Now 1 minute 45 seconds into flight. RD-180 continues to perform well at full thrust. Pump speeds and injector pressures look good.
All right, stand by now for booster jettison.
And now coming up on 2 minutes into flight, the Atlas V vehicle now weighs just 1/2 of its liftoff weight. RD-180 throttling down slightly as expected. Engine response continues to look good. And standing by for SRB jettison shortly.
Now look to your screen.
We have good
see
indication
it. There
of
it goes.
jettison of the solid rocket booster. Atlas V has gone to Q alpha limited closed loop steering. Vehicle body rates look good.
Now the next major milestone is
now 2 minutes 35 seconds into flight.
At 3 minutes and 25 seconds.
And the second stage RCS system press valve is opened. System now pressurizing to flight levels.
Flying at over 5,000 miles per hour.
Now 3 minutes into flight, approximately 1 minute remaining until BECO.
And he's talking about main engine cutoff, 1 minute.
RD-180 continues to look good. At pump speeds and injector pressures look good. 3 minutes, 15 seconds in.
All right, about to cut that booster.
Vehicle body rates look stable.
Seconds.
Now 3 minutes, 30 seconds in. RD-180 now throttling to maintain a constant 5G acceleration limit. Engine response looks good. And we've begun boost phase chill down. Now throttling to a 4.6G acceleration limit. Boost phase chill down has ended. Standing by for BECO. And we have BECO booster engine cutoff, standing by for stage
Atlas Centaur separation.
And we have good indication of Atlas Centaur separation. We have pre-start on the RL-10, standing by for ignition.
Next major milestone is the payload fairing. When that comes off,
we have ignition and full thrust on the RL-10. Chamber pressure looks good. Body rates look good.
That payload
and we have good indication of payload fairing jettison.
Right now.
This first burn of today's mission will last approximately 8 minutes. And the RCS system is now performing initial firings to warm up the RCS motor catalyst bed. System response looks good. And the Centaur is now 100 miles in altitude, 450 miles downrange distance, traveling at 11,800 miles per hour. 5 minutes, 10 seconds into flight.
You're listening to the voice of Patrick Moore, ULA's launch commentator.
Centaur propellant utilization system has gone to closed loop control.
Flight is looking very good at this point.
And RCS system now performing periodic firing for thermal conditioning of the system. System response looks good. And initial review of booster performance shows the booster performed close to pre-flight predictions.
So the next major milestone will be the Centaur first main engine cutoff, and we've got about, I'd say 5 to 6 minutes before that. Let's bring Mick Woltman back in. What did you think about the liftoff and the flight and separation? Looked pretty good from here.
Yeah, as we were listening to Patrick there, it was
Centaur
good to hear
has
all the mark
performed
events.
a roll-optimized telemetry link.
Hear all the mark events that were hit, and it seems like first stage performed very nominal, and RD1E performed very well to get the first stage and Centaur on its way. So things are looking really well on this flight.
That Centaur performing a thrust of about 22,000 pounds and flying in what, Mick, has been described to me as a very exact entry into orbit. It's not going all the way around the Earth, but it does have to have a certain amount of precision because it's a partial orbit around Earth.
Yeah, this first burn will get Centaur and Solar Orbiter into a semicircular orbit as we come around the Earth, and then we will get ready for our main engine start number 2, and that will get us onto our transfer trajectory orbit, or transfer trajectory to head off toward the sun. So, yeah, Centaur has to perform very well on this first burn to get into that semicircular park orbit.
And it's a lot of power that's needed in order to get this thing going, because she's going off into the deeper part of space, headed to the sun. We're getting a report of good performance so far, and that's excellent news. The team here, Mick, talk about the reaction at this point for the launch team. We heard a little bit of a celebration behind us.
Yeah, the team doesn't really get too excited here, but it is a mark event of first stage separation is important. Getting main engine start is very important too, as you said, getting Centaur on its way. The Aerojet Rocketdyne RL-10 performing very well right now in this first burn. But the team is starting to look at their data, continuing to follow the Centaur in flight on real-time data. The booster team is looking at their data after first stage separated to make sure everything performed well, doing a quick look of everything to make sure there's no anomalies in the flight so far. And so far we haven't seen anything or heard. So things are performing very well for this flight for Solar Orbiter on its way.
And that's good news, certainly for our European partners who are collaborating in this effort. The Solar Orbiter plans to unlock quite a few mysteries of the sun, as we have learned in the weeks rolling up to this. There's been a lot of time and effort that the teams have put into building this spacecraft, and then, of course, preparing for launch. Many years in the making. As we listen in now, we're getting a little more of an update. So far, continues to have good flight. This orbit, you were talking a little bit about this transfer orbit. It's using a planetary assist to get to its location ultimately, right?
Ultimately, once we get into our transfer orbit and Solar Orbiter's on its way to the sun, eventually they'll use the gravitational assist from Venus and to get into their orbit and trajectory heading for sun, so they can study the poles of the sun. And that, as we heard earlier from Josh, that'll be a couple years into the mission as they're doing that to maintain their trajectory and keep going. As you had said earlier, Centaur performing very well here on this first burn, and the teams are continuing to look at data and how it's performing. And we're happy to be at this point in the flight, but as you said, important to our ESA friends and Solar Orbiter and NASA, we still have a long way to go for payload separation. So mission is going well so far, and we will continue to follow this and see how Centaur performs to get our payload deployed successfully.
The spacecraft team certainly watching every moment of this very closely, as this is a very tense time for them, but no need to worry because at this point Centaur is taking her to the spot that she needs to go. And this Centaur, we were talking a little bit earlier, it's the last of its kind that is in flight now, but it's getting some upgrades. It's performing great, but what kind of improvements is it getting?
Yeah, I would say not Centaur mainly, but the RL-10 for
the engine. Right.
Yeah, it's the last single version of RL-10A that will fly. All vehicles in single stick from here on out will fly an upgraded RL-10C. However, the RL-10 4A will be used for human space flight. We need dual engine configurations on Centaur for human space flight to get astronauts back to the moon and then on to Mars. So RL-10-4A will still be flown and used, but in a dual configuration instead of single. So we're very happy to fly this last 4A in this single configuration with Solar Orbiter. It was very well suited for this mission and to perform the task that seems to be done.
And that dual engine has to provide a lot of power when it comes to, as you mentioned, the astronauts who are going to be going back up to the International Space Station from American soil once Boeing gets the go-ahead to fly. That dual engine, that power is needed because it's going to be a lot heavier.
A lot heavier, and we want more energy and controllability from the Centaur. We also have that dual engine setup for redundancy and controllability there.
We're going to get an update in just a moment from ULA's Scott Messer, but until then, we are tracking this flight and the successful flight that it has been so far. You're looking at a graphical representation of exactly what we're expecting the flight to look like, and everything is looking good at this point.
Matter of fact, Daryl, we just heard we've got main engine cutoff, so Centaur is shut down its engine for the first firing. Things look good, body rates have damped out, and everything looks good on this mission so far. So as we get ready to go, Centaur will continue to its mission by rolling and turning to the position it needs to get ready for main engine start 2, that transfer orbit or transfer trajectory that we talked about. Mm-hmm. The engine will need to get ready and chill down and get ready to fire up. This coast period that we're in will be about 30 minutes to get into position before we have to fire up the Centaur engine again. That'll be about 38, 39 minutes into the mission that we will do that, and it will fire for roughly 6 minutes to get into that transfer orbit. So Centaur performing very well. Atlas, Centaur, and Solar Orbiter on its way. So things are looking really good.
This is a bit of a coast phase, you would describe.
Coast phase, yes. Centaur performing well and doing some maneuvers here in this coast phase. So.
All right. And so while we monitor the coasting of the Centaur stage, we will also be monitoring the launch teams to let you know when they fire that engine back up. But in the meantime, we are going to send it back to the ASOC with Joshua Santora, who is joined by Scott Messer. Take it away, Joshua.
Hey, a lot more ahead, but we appreciate you both walking us through those first few very dynamic minutes of flight. Again, a lot happened, a lot to go, and now with me is Scott Messer. You're the United Launch Alliance Program Manager for NASA missions. Did I get that right?
Yes, you did.
Perfect. Awesome. So, Scott, got to feel good, like the booster's off the ground, we're on our way. So what's all happened so far?
Yeah, so it is a beautiful count. One of the most quiet counts I've ever been through.
Indeed.
And the liftoff was right on time. Everything has looked good so far. All the data we're getting back is looking really positive.
Yeah, and so how are you feeling right now? Because obviously, like, we've stolen you away in the middle of, like, the job is still happening. So appreciate you being here, but how are you feeling?
I'm super excited. It's always great to launch and get it off, but beginning of the window and everything looking great. I'm just really excited and thrilled to be meeting customer requirements.
Yeah, I mean, that's the name of the game, right?
Yeah, it certainly is.
So what's ahead left for us? Because obviously the ULA portion of the day is not done yet. So what's still to come?
Yeah, so we're in the middle now of about a 30-minute coast. The second stage engine will then start up again, burn for about another 7 minutes, a short 2-minute coast, and then separation at about 11:55ish.
Very cool. So 11:55. So that's still another. Is that a typical timeline? Because this is a lot of times we see for low Earth orbit flights, the booster is only used for 8 to 12 minutes or so. But this obviously we're using this rocket for on the order of an hour or so. Is that typical? Is that atypical?
No, it is very typical for NASA missions. I think probably most of them last about an hour on average.
Okay. And so what's next for ULA after obviously, we want today to go great. That's the focus right now. But kind of looking to the future, what's next for ULA?
Well, so this is the first launch for ULA in 2020.
Yeah, congrats.
The 137th successful launch, at least
so far. Yeah, absolutely,
and,
everything
we
looking
expect
great.
everything to go there. So we've got several other missions for NASA coming down the line. We've got a Mars mission in July of this year.
Mars 2020.
So that's really excited.
Very exciting.
And it's going to be a big year for ULA.
Awesome. And can you explain just a tiny bit more kind of about your role? Is it just focused on you're taking care of NASA missions? Is that, I mean, that's kind of what your description is. Is that true?
It is. I work with all the NASA science missions, and so Solar Orbiter, Mars 2020 coming up here, and it's our job to make sure that all the spacecraft requirements are met. We integrate with the spacecraft closely for several years and make sure that the rocket provides all the necessary requirements that the spacecraft asks for.
Great. Well, Scott, we appreciate you, appreciate the United Launch Alliance and all their work and helping us be successful to unlock secrets of the sun and everything else that goes on. So appreciate that. We're going to let you get back to monitoring this rocket and the rest of the flight. And I'm going to send you back out now to Blair out at the press site, who's got some guests with him.
Yeah, thanks so much, Joshua. I'm here with basically a solar dynamic duo, Holly Gilbert and Daniel Mueller. So great to have you guys on. I'm telling you, I'm so excited. Tell me your thoughts about the launch. We'll start with you, Holly.
Just one word, wow. I am just floored at how exciting and amazing it was. And I got to share it with my husband and my daughters and my partner in crime.
Yeah, dynamic duo, though, not on the crime side,
No.
Partner in good science.
That's right.
And Daniel, how about you?
I think this was picture perfect.
Yeah.
And suddenly you really felt like you're connected to the entire solar system. I mean, you're here on Earth and you're launching something that will go close to the sun, really out into space.
Yeah, and that brings up a good point. I was thinking of you guys earlier, and I thought, when you were starving scientists just getting out of school, did you ever think that you would be here at Kennedy Space Center watching not just a rocket launch, but a rocket launch carrying a mission and spacecraft that's so near and dear to your hearts? Holly, how about you?
I couldn't have even imagined this. Even though I've been in solar physics for many years, I just never thought I would actually witness something come to fruition like this and actually launch. It's amazing.
Yeah. Daniel.
Similar for me. I mean, I met Holly, I think, almost 20 years ago at a PhD school, and I mean, immediately knew this lady would go very far. I would not have expected to go along with her to this point, and so we're now sort of really, I mean, after many years of hard work and setbacks and excitement, we've now really made it. I mean, we are on our journey, and that's a big thing for me.
Yeah, and that's great too, because this whole week leading up to the launch and all the stuff we've done leading up to the launch in terms of preparing for the show, we've been hearing the international partnership, our friends at NASA and ESA, and how they've all worked together. And I just, seeing you guys here, talk a little bit about the relationship and working together on this particular mission.
Yeah, I mean, it's fantastic. I couldn't ask for a better project scientist team. I mean, it's a challenging thing having an international partnership. So we've had to, especially Daniel, has had to really work hard at making that all work, and 10 instrument teams, and it's an amazing partnership.
Yeah.
And I was lucky that I had the opportunity to work on the SOHO mission before, and I joined SOHO in the phase where it was fully operational, and I was working for ESA but actually based at NASA, so I could really form personal bonds with people that I still work with today, and that's been really key.
Well, I'm glad you brought that up, because as an observer to this, because I'm from the liberal arts side, it's really impressive to see that even though you're separated by miles and miles or kilometers, I guess, in some cases, in the science community, the boundaries sort of disappear. You kind of have the same objectives, and it's got to be a really, really great feeling to be able to know that you can trust and work with people of different backgrounds to get such important data.
Yeah, that's a really good point. I mean, we have one common goal, and that is to get the good science out of this mission. And I think we're going to succeed.
Yeah, and that's exactly the point I try to make also to younger people and school children. I mean, science really makes the borders disappear. It doesn't really matter where you're from. And in particular, if you have a real successful collaboration between different countries on an institutional level, that can really bring people much further than they might have dreamt of.
Oh, that's incredible. Sure. Thanks so much, guys. Thanks for being on the show. Continue to celebrate, and we'll go back to Joshua. Joshua and the ASOC, tell you what, congratulations on a good launch, and back to you, buddy.
Yeah, thanks, Blair. Same to the folks over there, Daniel and Holly. A great launch. Everybody's excited. So we're actually going to send you back out now to Laura, who has caught up with another one of those special people working behind the scenes for years leading up to these missions. Laura, take it away.
Thank you, Joshua. I'm joined by Anna Packros with the European Space Agency, and she is Solar Orbiter's payload manager. Anne, what did you think of that launch?
Well, really, it was a roller coaster of emotions for me. It was exciting, of course, after working 8 years on the project, to see it go on its way. But it's also I was a bit anxious, to see is everything going to go well? Is the signal going to be acquired in a few moments? So, yeah. Wait and see for now.
Okay, so Anne, I know you're an engineer, but tell us a little bit more about what the payload manager's responsibilities are.
So as payload manager, I'm responsible for the well-being of the 10 instruments. So making sure the spacecraft is compliant to what the instruments want to do, making sure the instruments are also ready to be integrated on the spacecraft, and sometimes chasing them a little bit to deliver on time. So it was really a big job to together with my team to take care of these 10 instruments on this mission.
So with 10 on board, that must have posed some challenges.
Right, exactly. So the 10 instruments are all different. It's like 10 different children, and all of them have their different needs. So it was sometimes a bit of a compromise we had to find to make sure they could all fit on board and live together on board this mission, because the point of Solar Orbiter is really to make this connection between the in-situ science and the remote sensing observations. So we really had to make them fit together, to take their measurements together.
So they're all on board, and Solar Orbiter is on the way. What's next for you?
So as I said, so we're going to acquire the first signal, and we're going then to start deploying all our antennas, all the boom, and after that, we have to check that all the instruments are working as expected. This is called the commissioning phase. And because we have 10 instruments, it lasts 2 to 3 months. We're going to take first measurements. For some instruments, we're going to take the first images already to make sure everything is working fine. And about June timeframe, when all this has been done, then we declare the mission commissioned, and they can go ahead on their way for the cruise phase and the science phase.
All right, so just a little bit longer, a little bit more work to do. But Joshua, you could see after a lot of years of hard work, you celebrate by coming all the way to Florida to Kennedy Space Center to watch a launch. Back to you.
Hey, listen, that's a great way to celebrate anything with rocket launches. So we appreciate that energy and enthusiasm and excitement from people like Anna, just because that helps us be just all the more excited to see them succeed and to succeed alongside of them through this international collaboration. So we're going to send you back over now to Daryl and Mick to check in on the status of our vehicle. Still in flight here. Daryl, Mick, how are we looking?
Well, looking good. Speaking of energy and enthusiasm, yeah. Mick here is a real rocket guy who loves watching these things every single time. You get pretty jazzed about it.
Yeah, and it's great to hear our international partners and how excited they are so far for this. We still have a little ways to go to get separation, but so far this has been a great launch, very quiet and very excited for this. Matter of fact, it's just been really nominal so far. That's good.
It all started at 11:03 Eastern, 00, as a matter of fact, right on time.
Actually, I don't have a conversion for that.
No conversion? You're letting me down. Nick, what happened?
No, it was right on time at 11:03 liftoff. The ULA, NASA, and ESA teams did a great job of coordinating and getting this rocket off the ground today.
So we continue to see a graphical representation of the Centaur in coast phase as it goes along. And trust me, the spacecraft team at this point is still very much very focused on the telemetry that's coming in from this spacecraft.
Yeah, absolutely. They're looking at that. The ULA and NASA teams are looking at the Centaur telemetry, making sure that things are going well. Matter of fact, we've got about 18 minutes still left in the coast. All Centaur systems are looking nominal with the RCS thrusters firing and settling the propellant back into the tanks, getting ready for that main engine start 2 to get us onto that transfer trajectory.
So talk us through the next steps that are coming. You know, we've got a little time to kind of talk about that. The Centaur second main engine will restart, and then it will fire for a period of time. Talk about the purpose of that once it's relit and then cut off again.
Yeah, so Centaur is in its coast phase right now in that semicircular orbit we talked about earlier, that parking orbit to get us started. And as we get into coast, the vehicle is performing a few maneuvers now using the reaction control thrusters to make sure that the liquid oxygen hydrogen that are still in the tanks are settled back down to the bottom of the tank to get ready for main engine start. That's a unique thing with the RL10 engine, is you can do multiple starts with it to support a mission like this and the trajectories you need. And the purpose of that is when they get ready for main engine start, they will fire that engine for 7 minutes to get us into that transfer trajectory orbit that we talked about, basically breaking out of that circular orbit around Earth and getting into a transfer orbit to head on towards the sun and start its science mission. So that's a very important burn to make sure we get out of the Earth orbit and on towards the sun.
And we can see in this animation here that there's subtle little firings there.
Yep, that's the RCS thrusters settling the vehicle and getting ready for that main engine start too.
All right, and so as we stand by for that, we're going to send it back to the ASOC. Joshua, we'll let you have it, and we'll continue to monitor the discussion here between the launch teams and the Centaur rocket in coast phase.
Thanks, guys. Appreciate that update. We are very excited. And as Solar Orbiter continues pressing on to spacecraft separation, let's take a closer look at what's ahead for this mighty explorer.
Ever since we've been pointing spacecraft at the sun, 2 regions on our star have been missing from satellite images. The sun's 2 poles have never been mapped because all the solar images we've built have remained in the ecliptic plane, the swath of space roughly aligned with the sun's equator, where all the planets orbit. A new mission from the European Space Agency and NASA called Solar Orbiter aims to escape this plane and take the very first images of the poles.
The planets are all moving and circling the sun, and so we already have some velocity going one way. If we want to launch up out of the ecliptic, it requires more energy.
To get outside the ecliptic plane, Solar Orbiter uses Earth's and Venus's gravity to slingshot itself into a view of the poles. The only other satellite to fly over the poles was Ulysses, which launched in 1990 to study the solar atmosphere. But Solar Orbiter will be the first mission to capture actual images of this hard-to-reach region. Scientists think the poles could be the missing piece to understanding what drives the sun's activity. Every 11 years, the sun's magnetic field flips. North becomes south and vice versa. This mysterious process has direct effects on Earth. Before the poles flip, solar activity reaches its peak. The number of eruptions increases, sending powerful bursts of solar material that can potentially harm our astronauts and satellites.
We don't really have a good understanding of the global solar behavior.
Another one of the mission's goals is to monitor how these eruptions and solar material travel through space. Using a suite of 10 instruments, Solar Orbiter observes an active region on the surface as it explodes, and then also takes measurements as the escaping material passes directly by the spacecraft.
Solar Orbiter will give us a comprehensive full view of the entire sun and how the sun is impacting throughout the entire solar system.
At closest approach, Solar Orbiter will be closer to the sun than Mercury, at a mere distance of 26 million miles away, the ideal distance to get a comprehensive view of the sun and its surrounding atmosphere. It will fly close to the sun every 6 months and endure temperatures more than 900 degrees Fahrenheit. To survive the intense radiation, a large titanium shield protects the instruments, while a carefully orchestrated dance of opening and closing eye holes in the shield allows the instruments to peep out at the right time. Other instruments will directly measure solar material from behind the shadow of the shield. All of these observations will tell us more about the sun than we've ever known before. And by the end of the 7-year mission, we will have seen our star in a completely new way.
Our understanding of the sun will change dramatically. I will say that we are living in a revolutionary moment in our field.
So we'll get back to Solar Orbiter in just a minute, but right now I'm joined by Kennedy Space Center Director, 4-time shuttle astronaut, space enthusiast, all-around good guy, second longest running center director actually now, coming up on the first and not too long, Bob Cabana.
Great to be here, Josh.
Hey, thanks for joining us. Appreciate you taking some time for us.
Another great launch by the ULA Atlas V and our launch services program here at the Kennedy Space Center.
So beautiful. So beautiful.
Oh, man. Awesome.
So I know that you love to kind of think big picture and talk big picture when it comes to the work that the Kennedy Space Center and NASA are doing. So how does the Solar Orbiter kind of fit in the big picture of what NASA is doing? How is this a part of our universe, so to speak?
Absolutely. So Solar Orbiter is on its way to study the sun, right? And one of the issues that we have is sending astronauts beyond our home planet. So with Artemis, we're going back to the moon, and the ultimate goal is get onto Mars, right?
Right.
And we need to understand better the sun and the environment beyond our home planet in order to protect astronauts from that harmful ultraviolet radiation, from all that's going on in space. So I think, this is great. This is what we have as a combination of science and our exploration programs working together so that we understand. So right now at Kennedy, I'm focused on two things. First off, I want to see commercial crew flying. I want to get astronauts to the International Space Station on a U.S. rocket from U.S. soil with two partners.
That's right.
Both SpaceX and Boeing.
Yes.
Got to get them both going. And then, the Artemis program. Artemis 1.
Artemis 1.
Kennedy Space Center is going to be ready for that rocket when it arrives. The Space Launch System, the core stage, is over at the Stennis Space Center right now in the B-2 test stand, getting ready for its green run, a complete testing of that rocket. They're doing modal testing, then they're going to fire the engines, full firing, and really document the rocket before they ship it to us for processing here. The Orion spacecraft, the Lockheed Martin Orion spacecraft, that's up at the Plumbrook facility at the Glenn Research Center up in Ohio, and it's going through thermal back testing. It's going to be back here around April timeframe, and then it'll be ready for processing. So we're going to get the spacecraft here, and then the core stage. We've already got solid rocket motor segments arriving, and we're going to send Orion on a test without crew in and around the moon, right? They're not going to land. It's just going to be without crew. It's going to go around the moon. We're going to really document the spacecraft, how it operates, and make sure that it's safe so that we can launch astronauts in 2022 to the moon. And then, the goal is having the next man and the first woman on the moon in 2024. That's a huge challenge that we've been given by the president, and we're going to do our very best to make that happen. And with the budget we got coming, I just can't wait,
Yeah, the budget hit the news cycle today, so people got a chance to see that a little bit. So there was definitely a nice little bump up for NASA from the president.
Yeah,
so
it's awesome.
We're super grateful for that.
Absolutely.
Obviously,
this is a great budget, man. We got to make this. We got the money. Now we got to go do it.
That's right. We got to go do it. So, and obviously Solar Orbiter playing a part in that, again, giving us that understanding of the world beyond the Van Allen belts that are so great in protecting us.
Complete package. Yep.
So anything else coming up for you, things you're thinking about? Obviously, we have Mars 2020 coming up this year.
Yeah, Mars 2020 ships here on Tuesday on its way to the Kennedy Space Center from JPL. And I look back on the Curiosity rover, and I thought, that was so cool. It came here, and I got to see it. I put a bunny suit on, went in and saw it when it was over in the PHSF, getting processed and everything. And then I went out to JPL when it landed. And this is going to be the same thing. It's another rover the same size as Curiosity that we're putting down on the surface of Mars, right? And I thought, well, it's no big deal. They're watching it. It's all delayed. It's all automated. It's not like human spaceflight, human in the loop and all that stuff. And they're seeing it 8 minutes after it happened. It was one of the most exciting things I've ever done. It was so cool, getting the reports back and watching it, and and then to see that rover on Mars.
Yeah, we've gotten some amazing imagery back.
Now we got to get humans there.
Yes.
Rovers, they're the precursors to sending humans. But that's the goal in the 2030s, to be having humans on the surface of Mars. I can't wait.
Yeah, we're all excited for that. Obviously, this rover is the same size but different science instruments, so it's not a one-for-one copy.
No, I know.
And we also have a helicopter on board this time, which is super exciting.
Way
cool.
Cool.
I'm going to let you get back and listen into the rest of the flight here, and I'm going to send you back out now to Blair, who's out.
Oh, awesome. Those NASA Edge guys are really cool.
Yes, say hello. Blair's online now.
Hey, Blair.
Hey, Bob, I got to tell you, with Curiosity, there were 7 minutes of terror. With Bob Cabana, you get 7 minutes of pure, unadulterated enthusiasm. They're really exciting to hear from him. But we're also very excited about Solar Orbiter tonight. And before the launch, I had a chance to sit down with Cesar Garcia, the project manager from ESA for Solar Orbiter. Let's hear from him. We're here at Astrotech Space Operation with European Space Agency Project Manager for the Solar Orbiter, Cesar Garcia. Cesar, thanks so much for being here today.
Thanks you for having me.
The first question I want to ask you is, tell us a little bit about the overall mission for Solar Orbiter.
Okay, Solar Orbiter mission, as the name shows, it's a space mission that will orbit around the Sun in ways which we have not done before. We will be different in that we will be relatively close to the Sun, and we will also change the orbital plane so that we can observe the poles of the Sun. We will investigate also the solar wind and features close to the surface of the Sun. Then they will also look into the heliosphere, and we all live in the heliosphere of the Sun. And finally, they will investigate the reasons why we have this 11-year cycle and what drives the solar variability.
Some of the instruments are going to be capturing images. What are those images going to look like?
Well, we capture images in various frequencies across the spectrum. Normally, science instruments, or well, also Earth observation instruments, they don't take what we call white light pictures. We try to take pictures in a very small frequency band, and then we combine those various frequencies to create broad spectrum images. Now, Solar Orbiter has instruments in the visible, so the various colors of the visible, a little bit in the infrared, also in the ultraviolet spectrum, and all the way up to the X-rays. So the various instruments will detect these images in different ways, and what the scientists do, they combine various frequencies to create, well, pretty pictures like the one we have in the background here. That's one element, and the second element is that the various instruments, they have different fields of view. Some of the instruments will be able to capture the complete solar disk, and at the same time they will be able to look with very high resolution into very small portions of the Sun. Some of the instruments will be looking at the rim, or to make things more interesting, when one of the instruments detects a feature of interest, he will send automatically a trigger to the other instruments so that they can also change mode of operation and focus on that specific feature to learn more about it. And if that involves, for instance, the ejection of material or a change to the solar wind, when that happens on the spacecraft, then also the in situ instruments will be able to react and to sense that specific feature. And that combination of things which happen on the surface or close to the surface of the Sun, and then at the location, later on at the location of the spacecraft, is one of the key features and unique features of Solar Orbiter.
There are a lot of fascinating and important instruments on the spacecraft. If the scientists see something interesting during an observation, do they have the ability to adapt and sort of reorient to take a look at that interesting event?
Yeah, they want to maximize the opportunities, of course, and there are several ways of doing that. One way is something that we call the short-term planning, as opposed to long-term planning. Long-term planning is what the scientists do. They plan every instrument, every mode of operation, like 6 months in advance. However, every 24 hours, if they see a particular feature, or if there is a signal coming from a different space mission or from the ground, then they can change in very short time what the instruments will be doing in the next observation day.
Well, it must feel really good now because everything clearly is here on the spacecraft and ready to go. It's got to be a good sense of accomplishment.
I think so. I think that overall, when you develop a space mission, there are always many challenges. And there are moments where you don't really know if there is a technical solution for the problems you're facing. Then, it takes time, it takes effort, it takes teamwork. And now, once you move to the launch space, then it's like an army. I mean, different armies, they are sort of coming together, and sometimes people who you never met, but they've been working on this mission for years. Then you get to meet those people, and then you realize that everybody's working to the same goal. And I think it's a real sense of accomplishment and achievement, yeah.
Well, and here we have it, a successful launch, and that team that Cesar mentioned is very proud and excited at this time. And we just want to congratulate them. And back to you, Joshua. Take it away.
Hey, thanks, Blair. Yeah, obviously that international collaboration is such a theme running throughout this program and throughout this entire mission. We're glad to have them on board. We did want to kind of cycle back again and go through the fact that this evening, there was a Northrop Grumman Antares scheduled to launch, and it was scrubbed after off-nominal readings from a ground support sensor. Northrop Grumman and NASA have set the next launch attempt to no earlier than February 13th at 4:06 p.m. Eastern Time due to unfavorable weather forecast over the next 2 days and time required to address the ground support issue. NASA TV coverage of the launch will begin at about 3:30 p.m. Eastern Time, and teams will refresh 24-hour late load cargo the day before. The Antares rocket and Cygnus spacecraft remain healthy. Launch Thursday would result in a capture of Cygnus on Saturday, February 15th. For more information, visit nasa.gov/Northrop Grumman and nasa.gov. We're going to send you back over now to Mick and Daryl, who are going to take you through spacecraft separation. So this is still not quite the end of the mission today, but another huge milestone. Daryl, Mick, take it away.
That's right, Joshua. It's a big moment that everybody is really anticipating here at this this portion of the mission. He's Mick Woltman. I'm Daryl Nail. 25 years as a vehicle systems engineer, so he's got all the knowledge to help break this down.
And I will tell you, it's exciting every time we launch. The next mission is the most important, and tonight was great to see Solar Orbiter get off the ground. And like you said, we still have some things to do to make sure it's a mission success. But we're moving along, and things are looking really well. Centaur is in its phases of settling propellants and getting ready for that main engine start 2 coming up. So things are looking really good.
Yeah, and he's not just saying that, folks. I literally got to watch him get a little giddy as we're getting ready to lift off. So it's an exciting moment. We are in that coast phase. We've been in this coast phase for quite a period of time now. We've got a few minutes left in it, and as you mentioned before, you can see in this graphical representation that there are thrusters that are being fired from time to time to settle that fuel inside of the Centaur, and that will allow it to restart. It's really one of the keys to this vehicle, and this vehicle, in fact, is pretty reliable. It's gotten really good at doing this, and it goes all the way back to the 1960s.
Yeah, Centaur was designed for multiple engine starts and missions like this, so it's a very reliable vehicle to get that way. We're seeing now that we have pre-chill down on the engine, which means the engine is chilling down and getting ready for fuels to get through and start up ignition. The igniters would fire, and we would get MES 2. We're standing by for that call right now. We should be coming up on main engine start fairly shortly.
Chamber pressure looks good.
So we just heard that we have full thrust, and main engine has started, and body rates look good for this 7-minute burn of the Centaur engine.
Now, this is a key burn as it refires that engine and starts to get into that transfer orbit, right? It's partially gone around the Earth, and now it needs to get on to its destination.
Yeah, it's gonna fire and get us into that transfer trajectory to get Solar Orbiter on its way to the Sun, which is very important for us. So once this burn happens, we get through this successful 7-minute burn, we'll be coming up on spacecraft separation, which will be another major milestone for us. However, we will not be celebrating quite yet. Solar Orbiter has to get moving on its way, and we have to make sure we acquire signal from the satellite, which will happen about 4 minutes after separation. So that'll be a major milestone for the spacecraft crew and the launch team. But this milestone of main engine start and this second burn that we refer to, is a major step in the right direction.
And of course, this is kind of the safe period of this entire launch and mission. The toughest part is getting it off the ground. We go back to 11:03 p.m. Eastern time when it lifted off. That is a big moment to see that thing coming off that pad, riding a controlled explosion up into space.
The team does a very good job. They make it look easy. Matter of fact, as we heard from Scott Messer earlier, this was the quietest count he's heard in quite a while, and that is just a shout out to the teams and how well they have done. All the collaboration between the international partner, the United Space Force, NASA, LSP, ULA, all the teams working together to make sure the count happened on time, and the vehicle got off at 11:03, specifically at the beginning of our window. That is just that's always exciting to me to watch that. Every launch is just amazing to see that fire and lift off.
We've been flying for about 45.5 minutes to this point in time, and the ULA managers have been working this launch for that entire time. And as Mick said, they are continuing to be very diligent in tracking the telemetry and tracking the flight of the Centaur upper stage. It is in the midst of a 7-minute burn, a few minutes left in that one as it positions itself to get into that proper orbit. It is going to use a gravity assist eventually, much later down the road. But that is part of the deal in order to get this thing close to the sun so it can start gathering its data. It's got a lot of interesting instruments on board. In particular, one of the ones that I find, one of the aspects of this spacecraft that I find most interesting is its ability to open up little ports on its heat shield. It's going to get so close to the sun, and it's going to point its heat shield at the sun, but it's got little ports that it opens up inside the space, inside the heat shield to allow the sun to come through, which is an amazing thing. It's got to cool the instruments because it's going to be so incredibly hot.
Yeah, the heat shield is a specific part of this spacecraft that's required. As you said, it gets really close to the sun, a couple million miles, which is close for a spacecraft.
Right.
And but those little apertures inside the heat shield get opened at particular times to catch things, catch sunlight, catch ultraviolet light, test things in the instrument, and help protect the instrument. So the satellite basically rides around the sun with that heat shield pointing at the sun at all times. Another unique feature for myself as an engineer that I thought was really neat of this satellite was the solar panels when they come out. Normally we see on a satellite, solar panels come out and they're pretty flat in order to get sunlight to power the systems, right? Charge the batteries and do all the other things on board. These, because we're so close to the sun, the team actually has to turn these solar panels almost at 78 degrees to keep them from getting too hot and collecting. But they have, as Ian Walters from Airbus said, who designed this spacecraft, said, we do not have a problem with power on the solar panels.
There's a problem with heat.
Exactly. We have a problem with heat. So that's a unique thing about the spacecraft that I find interesting.
Absolutely. Just a little less than 2 minutes left in this burn, this second burn of the Centaur upper stage as it gets ready to transfer into its new orbit. It's an exciting time. We certainly know that the team is anticipating that cutoff of that engine, but also, more importantly, looking for the separation of the spacecraft, which is coming up just a few minutes after that, and then followed by, hopefully, some signal acquisition.
Absolutely.
The spacecraft tells us, I'm here. It's kind of opened its eyes, so to speak, right, and says, I'm in position, I'm headed in the right direction.
Yeah, the spacecraft team knows that the satellite's where it's supposed to be and that the Atlas Centaur has delivered it on the proper orbit, as you were talking earlier, that precise orbit that we need. We've had 2 burns now. This is the second burn, and that second burn of this Centaur will put it in that orbit trajectory or transfer trajectory that the team is looking for. So acquisition of signal after SEP is very important. But we're still getting there. So 49 minutes into flight, and things are going well. Centaur pressures on the engine look really good. Engine continues to perform nominally, and the RCS thrusters continue to keep Centaur where it needs to be.
A little less than a minute until main engine cutoff. You can see in the graphical representation this Centaur continues to fly with solar orbiter at the very front of it. That RL-10 firing behind it as it goes. And just about 20 seconds now until we see that engine cut off and go into that next coast phase. So let's watch now and listen in as they get close to this moment. This is the Centaur's second main engine cutoff.
Body rates look good.
So yeah, Centaur continues to perform nominally. Body rates on Centaur look really good.
Standing by for cutoff in approximately 10 seconds.
Standing by here for main engine cutoff.
And we have MECO, main engine cutoff.
And there you go.
Body rate stamped out nicely from the cutoff transient.
Main engine cutoff from the Centaur, that's great. That second burn has performed. So now we're about 3 minutes away from spacecraft separation, our next big milestone. So I can tell you the launch team is very happy on how Centaur performed. And looking at the data, Centaur performed very well on this second burn, getting solar orbiter onto that transfer trajectory. So spacecraft separation will be our next milestone, Daryl.
Yeah, and if we can take a shot of the Mission Director Center here, we had a little bit of a celebration after that main engine cutoff. I believe that was probably the spacecraft team back there that was cheering.
I think it might have been a little bit of both.
A little bit of both.
Yeah, a little bit of both, because Centaur performed very well looking at the telemetry data here. And so the launch vehicle team is very happy with RL-10 and Centaur performance tonight.
A lot of pride, and deservedly so. Talk about now what the Centaur is doing as it prepares for this separation event.
Yeah, Centaur is maneuvering into position, getting ready to separate spacecraft on the trajectory that it needs to head off into this transfer trajectory. So the RCS thrusters and everything are moving the vehicle around since body rates have slowed down, and it's positioning itself in for to deliver Solar Orbiter onto its transfer trajectory.
And you can see in that representation how it is maneuvering to get into that position, just a few seconds away from that separation now. In fact, just less than a minute. The Centaur continues to perform well, and it is positioning itself at this very moment. What's the actual mechanical procedure that takes place in order for this spacecraft to separate from the Centaur?
Well, first thing is, as we said, main engine start, main engine cutoff on that second burn was very important to get us where we need to be. Now Centaur has positioned itself, and as you can see in the STK firing there, the graphic, the RCS continues to fire to settle out the body rates and the Centaur to get it into position and a stable mode to separate this spacecraft. So the erection control system continues to fire at a 50% duty cycle to keep that vehicle stable and where it needs to be to separate spacecraft SEP. We want to null all the body rates out so that we can make sure that we get good separation and no tip-off.
Just a few seconds away from separation, you're about to see some celebration here at the various control rooms across the Cape and across the country.
The Solar Orbiter spacecraft.
So we've just heard from Patrick Moore.
There
Good indication of separation. That is a huge milestone for the Solar Orbiter team. Daryl, as you see in the ASOC there, they are celebrating.
Yeah, and they were celebrating here in the Mission Directors Center as well. You can see some hugs and handshakes going around. This is, of course, a big mission for ULA, especially given the collaboration that took place. You're talking about 22 different countries that were involved in this spacecraft, the Solar Orbiter. We're talking about a decade or more in the planning. So certainly United Launch Alliance has a lot to be happy about as they celebrate. Just a couple of miles from us there, the folks there standing up from their console. That's Tim Dunn, and I believe in the lower left corner there, NASA's
launch
Tim
manager,
Dunn, launch director, and giving some good handshakes all the way around for their hard work this evening, late in the evening.
Yeah.
I should mention that.
Yeah, the launch team is very happy. I've been looking at the data for Centaur, and the quick look looks like Centaur performed very well within our pre-flight predictions to get the Solar Orbiter where it needed to be. And as you just heard and saw the celebration, a successful separation. Now we're just waiting to hear from our spacecraft team, roughly 2 minutes from now, hopefully, that we will get acquisition of signal and make sure that everything is going well with the Solar Orbiter spacecraft. So the mission is a success so far, but we still have a little bit more to go to make sure Solar Orbiter is on its way.
Holding out for those final moments as they pass to get this spacecraft separation. We know the spacecraft team is here with us, just behind us here in the Mission Directors Center. They've been pretty calm and collected throughout their work, and you know them.
Oh, yeah, very well. The spacecraft team, and you're going to talk to them a little bit later, how things are going from that aspect, and I think they're going to be very happy. You can see here the Denver Ops Center in Denver, Colorado. The ULA engineering team is still looking at data on performance of the launch vehicle. Even though we've had a successful SEP, things still get looked at to make sure everything was within our pre-flight predictions from that aspect. Again, a very exciting moment. I'm very excited that we are here and looking forward to get acquisition for that. So things are going well with the teams and as we proceed forward.
So now the Centaur has separated away, and there's a little bit of business that it actually has to do as it leaves the spacecraft.
Yeah, now that the spacecraft has left, Centaur has to perform a couple maneuvers to get out of the way and make sure that it's basically done with its mission so the solar orbiter can move on and we have no interferences and things like that. So it is going to fire its thrusters a little bit longer to make sure that it's well away from solar orbiter as we continue with the mission and wait for acquisition of signal. And as you see there on your screen, that's a picture of the Mission Director Center here at AE, where our ESA friends are sitting and waiting on that acquisition signal from their spacecraft. So I'm looking forward to seeing and hearing that from them and see how excited they are to know that Solar Orbiter is out there and doing its thing.
That's right, and just a few seconds away from that event, Mick, and the spacecraft team is sitting in the front row that you see there on the left portion of your screen. So once that confirmation comes in that the spacecraft has indeed sent its signal and they verify that it is in the place that it is expected, you can probably expect to see a great amount of relief and celebration from that front row here at the Mission Directors Center at the Cape Canaveral Air Force Station. Of course, we're in the broadcast booth to the upper right with our backs to you, but it's not trying to be impolite, but we are monitoring our systems here as well.
Yeah, well, like you said, we're looking at data too, and we're waiting to see that. Hopefully, we're going to hear that we get acquisition from signals from the spacecraft, but we'll continue to wait and hear that from our ESA friends. So with that, I think we are ready to throw it back over to Joshua in the ASOC, who's with my good friend and who's excited about this launch, my favorite NASA launch manager, Mr. Tim Dunn.
Can't do much better introduction than that. Take it away, guys.
Is he saying that because Omar is not here? Is that why he's saying
Only
that?
because Omar's not here.
I see.
You know, Mick, Omar is in the next room.
No, yeah, and this is NASA launch manager Tim Dunn. He's the NASA launch manager for this mission.
Yes.
So appreciate you taking a few minutes away. We kind of keep saying this, that we're not done yet.
Right.
But we're close. We're getting there.
Close. We keep getting there.
Everything's going well. So tell us about the flight so far. How do we do?
So flight's going really well so far. I'm a little bit tamped down on my enthusiasm just because we want to get a few key mark events from the spacecraft.
Yes.
But obviously, countdown went incredibly smooth. Worked a couple of minor issues in the background. Nothing of significance. Boy, gorgeous weather. Range instrumentation from the 45th Space Wing was exceptional today. The ULA team, I can't say enough about the ULA team. Just incredible how they're able to process and prepare this rocket. So a great countdown, beautiful night liftoff here on the Space Coast. I hope folks locally you enjoyed it. I hope folks watching on NASA TV, I know you guys showed them some great shots. Had to be beautiful out there. We felt the rumble here in the Mission Director Center in the ASOC, and nothing like a successful launch. So obviously we got great spacecrafts up a few minutes ago, and now we're just waiting for a couple of mark events, and then we'll want to tell you the full story and share the real excitement then.
There you go. Yeah, and we're excited for the folks from here, from ESA, as well as the tourists in the area and just employees and everybody. It was a beautiful night out, clear skies. So if you were outside, you were treated to a beautiful launch. Just you could see that thing go almost to the horizon, I think.
Yep. Gorgeous.
So, Tim, again, appreciate you stopping by. I don't want to keep you too long because I know that you're still focused on that because the job is not done yet for today.
All right.
So
look forward to coming back and talking to you in a few minutes, though.
Thanks
Joe.
for stopping by. And if this is not excited, I can't wait for super excited Tim. So,
all right.
Thanks, Tim. We're actually going to send you now. We want to look at one of the greatest mysteries of the sun, and that's that in the corona, the temperature is actually millions of degrees hotter than actually on the surface of the sun. We call it the coronal heating problem. Take a look.
The sun's core is the hottest part of the sun, but our star's temperature doesn't behave as you might expect. The core is roughly 27 million degrees Fahrenheit and 10 times more dense than gold. As you move outward, the layers of the sun become cooler and less dense. Something unusual, however, occurs when you reach the outermost layer. While the surface is around 10,000 degrees Fahrenheit, the corona, the sun's outer atmosphere, is several hundred times hotter. That's the opposite of what happens with a fire. When it gets cooler, the farther away you get. Scientists call this the coronal heating problem, and evidence for this was first uncovered during an eclipse in the 1800s.
The corona is usually hard to see. It's too dim to be seen next to the sun's bright body. But it can be seen with the naked eye when the moon blocks the sun during a total solar eclipse. To understand how this mystery was discovered, it helps to know how scientists started studying the chemical properties of materials on Earth. In the early 1800s, instruments named spectroscopes were invented to identify materials that emit light when heated. Light enters the spectroscope and is filtered through a tiny hole to isolate a single area. It then bounces off a special grating that disperses light into its different wavelengths. While sunlight contains every wavelength, scientists discovered that every chemical element and compound contains a unique pattern of wavelengths that allows scientists to determine the composition of light sources. It wasn't long before astronomers started extracting information from the light of distant stellar objects. In 1869, two scientists independently decided to point a spectroscope toward the corona during a total solar eclipse. As the sun's light disappeared, the pattern of wavelengths changed. They saw something they had never seen before. A bright green line that did not relate to any element found on Earth. For a short while, scientists named it coronium. It wasn't until 70 years later that a Swedish scientist discovered that these lines were the result of elements such as iron being stripped of its electrons. Every element has a specific number of electrons surrounding the nucleus. As each electron is removed, more energy is needed to remove the next one. The green line shows that iron has been stripped of 13 of its 26 electrons, indicating that the corona needed to be millions of degrees, counterintuitively far hotter than the sun's surface. Scientists have since proposed a variety of theories for what mechanisms could be adding that extra heat into the atmosphere. One theory suggests that small waves in the sun's surface pushes particles and heat into the atmosphere, a bit like how ocean waves push surfers. Another theory suggests small bomb-like explosions from the realignment of the sun's magnetic field create heat. Many scientists think it may be a mix of both. We've studied the corona from Earth during many eclipses, but to solve our star's biggest mystery, we have to make direct observations from the region itself.
We just heard great news. The signal acquisition has been confirmed, so another check on the list of things that need to go right today. And so that list is coming together very beautifully. We're going to send you now out to NASA Edge's Franklin Fitzgerald to take a look and talk to an astrophysicist, a solar astrophysicist. Franklin?
Thank you, Joshua. Yeah, I'm here with Dr. Alex Young, who is an astrophysicist from Goddard. Alex, how are you today?
I'm doing fantastic. How are you?
I'm doing pretty good. You saw the launch from Banana Creek. How was it?
It was spectacular. It was so spectacular. It's not the first launch, but it's the first time I've seen one from there, and it was amazing. And being with that crowd was amazing.
That is good to hear. Now, I know you are very interested in getting to the science of Solar Orbiter. Tell me about what you most are looking forward to.
Well, I mean, one of the most obvious things that comes to mind is the unique view of the poles. We have never imaged the poles of the sun. We've never gathered detailed magnetic field observations of the poles directly. And that's a really, really important thing for understanding the sun's activity cycle. And so that is really, really critical because that's what, the sun's magnetic activity drives space weather. And so this is going to be a game changer with these kind of observations from Solar Orbiter.
Now, you got a couple years until you start gathering data from Solar Orbiter, but you do have a recent solar mission where you've been receiving some data, and that's Parker Solar Probe. Can you give us a little update on that?
Yeah, so Parker Solar Probe has already been around the sun 3 times. It's going to make 24 orbits, and each one, it's every time it passes Venus, which will give it a little kick, it'll go closer and closer. But they've already brought back data. they've already brought back tons of data and have gathered amazing number of questions that they hadn't expected. You know, they've made amazing discoveries already. They haven't even gotten to the final goal, and we have a new understanding already of the turbulence, sort of the region where the solar wind becomes turbulent, where the solar wind sort of relaxes. We found out that the magnetic fields that come away from the sun actually do these crazy 180 turns back. They call those switchbacks. And, you know, some of the scientists have even discovered something non-solar. They've seen some of the dust trails that are what cause meteor showers here on Earth due to comets and asteroids that they've been trying to see for a long time, but they're so difficult to find because so close to the sun, it's too bright. But we've used really, really sensitive cameras on the side of the spacecraft that have seen these. So it is so cool, and this is one of the things, you know, you and I have talked about. One of the things that excites me so much about science is the fact that you always come back with more questions than you do answers. And that's what really drives science forward.
Speaking about the science a little bit more, is there going to be any overlap in the type of discoveries you'll make between Solar Orbiter and Parker?
Oh, absolutely. So these are really two complementary missions, because Solar Orbiter is going to get really, really close and give us a lot of detail of what's happening in the regions where we think the solar wind is accelerated away from the sun, where we think energetic particles are accelerated from the sun. But Solar Orbiter is going to be slightly farther out and give us more details as to what's happening in these transition regions as things are moving out, as well as this perspective, you know, out of the plane of the solar system. And so having all of these missions so close, because even though Solar Orbiter is not as close as Parker Solar Probe, it's still in an unknown area. It's still in a region which we've barely sampled. It's closer than we've been before, not including Solar Orbiter. It's closer than we've ever been before. So both of these are sampling a really unique area and a really important area in the sun. And it's the data is going to continue to surprise us and excite us.
Hey, Alex, it is great to have you on the show. Great seeing you again, and we look forward to getting more data from Parker Solar Probe and from the Solar Orbiter.
Absolutely.
Joshua, back to you.
So much. Appreciate that. Good insight there. And I'm joined now by Omar Baez, who today is the assistant launch manager, NASA launch manager. And so you and Tim flip-flop roles depending upon the mission. So today Tim was the manager and you're the assistant. But then in the future, coming up this year, what missions are yours? What are you the lead for?
So we talked about it earlier. Bob Cabana was here. He started talking about the Mars 2020 mission.
Yes.
That's our next mission up. We expect the rover to be arriving this week. Parts of it have already arrived, and we really are looking forward to that. That's going to go on an Atlas with a couple of more solid rocket motors in this one here to get it out to the Mars for its 7-month voyage. We plan to launch that on July 17th and hopefully land on Mars February 18th of 2021, 7-month voyage. Really exciting mission. The country's going to be overwhelmed. The world's going to be overwhelmed when we see this helicopter as its payload, and not a primary instrument, but really cool stuff going on with that the public's going to really love. The mission's out there to get cache some samples and hopefully get a sample return mission to keep that continuity going. And we're super excited about doing that this summer.
Yeah, that's awesome. So you're the lead for that one?
I am the launch director for the Mars 2020 mission.
Very cool. So tell me a little bit about the relationship that you and Tim have on launch day. Obviously, one of you's launch manager, one of you is the assistant launch manager. So practically speaking, what does that mean?
We're completely interchangeable.
Okay.
So no matter what's going on, things get busy. We're able to take on that. If we get really busy, the other one can take some load off of the primary guy. That is what I'm there for today, is to do those things where when he's time crunched, I can help him out with. Likewise, when he's, stuff happens. You have to go to the bathroom. You have to eat.
Sure. The practical things.
You got to step in.
Yeah, very good. So, and I think that's a really important point to key on, is that it's really an interchangeable where essentially you just have to have one person in charge. And so it's him, but ultimately you all kind of carry that weight together.
Correct.
So beyond Mars 2020, what's ahead for the Launch Services Program? Obviously, I think we're coming up on 22 years of existence. So what's the next decade hold for Launch Services Program?
There's an array of missions. It's been I've been with the Launch Services Program for the 20 years and a couple of years before that when we were the predecessor organization, and we've assaulted all the planets, and in
a very research-oriented way.
Absolutely, and it's phenomenal to think back. An organization that was very tiny, a small portion of the agency, we weren't even noticed. We're able to reach out to the furthest planetary bodies around us, and it's been a real pleasure, and we're going to continue doing that. And as Bob said earlier, these missions are precursors to humans going out beyond Earth's orbit, and we really look forward to doing all the pre-work that we can with automation before the human gets out there.
Sure, good. Does this job ever get old? You've been doing this a while now. Do you ever get tired of sitting there, another launch countdown? Does it ever feel that way?
No. It's always exciting. I've got the most, I'm most fortunate in the job that I do. I really love it. Someday there will be a sunset for me. Just this prior week, I become eligible for retirement.
Uh-oh.
Not that I'm going, but it's a good feeling, and it's been a great career. And I intend to stay around for a couple of more years.
Very good. Is there anything else in your career that you have your eyes set on? Like, what's above, what's better than a launch director?
I can't think of it right now, except being retired and having a margarita somewhere.
All right, and with that, Omar, I will let you get back. Again, we kind of keep saying this, but it's true. We've done a lot. We're not quite done yet. So I want to make sure you get back and support Tim as we close out this mission, close out this launch activity today.
Okay.
Thanks, Omar. We're going to leave you now with this video. Not leave you now, but we're going to check in with this video. We showed it earlier, but this is a preview of the LSP missions for this year, 2020. Obviously, we're incredibly grateful for the support and the service of the Launch Services Program and all that they do, helping make all of this science research and robotic exploration possible. We're going to send you now over for an update on where we are with the spacecraft. Daryl and Nick, how are we looking?
Joshua, looking good so far. We're here at the Mission Directors Center, where behind us the spacecraft team from the European Space Agency continues to work this mission as they are communicating with their spacecraft. We got a little bit of an update. We heard the project manager, Cesar Garcia, talk over the audio loops. He gave a little bit of an update.
Yeah, he confirmed that we did get acquisition signal, as Joshua reported out, so we know that Solar Orbiter is on its way, and the folks in Germany have acquired Solar Orbiter at the right position. That tells me the launch vehicle did a great job tonight of delivering them in the orbit they needed to head off. We did hear that they started their auto sequences, which is the software programs on board of the spacecraft to get ready for solar array deployment that we're waiting on. So that is in work, and what's been reported so far is that all things are nominal and proceeding per the timeline. So we're just waiting to hear from them if solar array deployment and that they're getting good sun signals.
About an hour and 15 minutes ago, we launched here from the Cape Canaveral Air Force Station on an Atlas V rocket bound for the sun. The Solar Orbiter spacecraft on top. It was a good flight. Initially off the ground, we saw the good separation, and now we're getting some celebration here at the MDC. We're getting more information on that solar array deployment. As you can see there, they just erupted in applause on the front row. That is the spacecraft team, all from overseas. The European Space Agency and their partners with Airbus Defence and Space. They have celebrated.
Yeah, we've seen the celebration here in the MDC. I haven't heard anything or confirmed whether solar arrays were deployed or not, but I'm going to assume that based on their celebration, something in the sequence happened the way it was supposed to be. So we'll continue to monitor and find out what's going on, but based on that, I would say things are going very well for Solar Orbiter, and we'll just wait for that confirmation, verbal confirmation that solar arrays were deployed, but we'll see. It's been an exciting night with the liftoff of Solar Orbiter on the Atlas V 411 vehicle, and things are going well so far. So we're getting to that point that I like to say we can really celebrate that things have all gone successful.
It's a good moment in time for this mission, which has been going for an hour and 17 minutes now as we approach just 20 minutes after midnight here on the East Coast. There was a little bit of a treat for us, although we can't quite show this yet, but we certainly saw it on our screens where we saw the replay of a spacecraft separation event. Certainly they confirmed that there was spacecraft separation, but to see that visually, it looked really good.
Yeah, it is. The team had a camera on board. Unfortunately, based on the flight and the orbit that we were putting Solar Orbiter into, you could not get that real time and live. So the team had stored that in telemetry, downloaded it once they got over a ground station that they could get that. They're verifying that video and making sure it's all good. So I'm sure in the days to come you will see some live video of Solar Orbiter's separation from the Atlas V, but it's always good to get that confirmation from the spacecraft and from the team that everything's going well. And as you see on the screen there, we have live coverage from the MDC here at AE on the right-hand side, and on the left we have a live shot of the ESOC in Germany from the ESA team. So things are going well there, and hope that all is progressing forward for solar array deployment on Solar Orbiter.
Yeah, that ESOC stands for European Space Operations Center that you're looking at right there. That is in Germany, and that is a live view of the control team there and the operations that have been going on there. Those people very excited because there are 22 different countries that all came together in order to make Solar Orbiter happen, and that control room was part of the launch today, and we're getting a live peek in to how they do things overseas.
Yeah, and that's actually a very important part of this mission. The ESOC is where the team, the ESA team, as you stated, is controlling Solar Orbiter right now, and they're performing their sequences to get those solar arrays deployed and in position. That team is monitoring the spacecraft very closely. They're communicating that status back to Cesar Garcia here in the MDC. And, we'll hopefully hear from Cesar a little bit later in the show here. But that team is doing a lot of work to make sure Solar Orbiter is performing well and doing what they have to accomplish to get solar arrays out. So we'll continue to monitor that situation and see how that goes.
Watching that very closely, and as we await solar the solar array deployment, certainly they have a lot of work to do in the future because it will be several years before Solar Orbiter is in position to start gathering data and doing its science on the sun. So that operations center in Germany that you're looking at on the left, they've got a lot of work ahead of them.
Oh, absolutely. In the next few months, they have a lot of checkout they want to do to verify that everything is operational and working after that smooth ride on the Atlas V tonight. But they want to double check and triple check all that stuff before they head on their way. Make sure everything is working, all the instruments are performing well. Check out those little apertures that you like so much on the heat
on the heat shield. I
on
like
the heat
that.
shield, to make sure they're working well,
Yeah.
right? Because you don't want those to fail once you get to the sun. And so the team will be doing a lot of checkout on the satellite over the next few months and possibly year to get ready for that. And they'll get into their gravity assist maneuvers around Venus and then head to the sun. And then come back and do some more work. And as we heard earlier in the show, 2 to 4 years, as Josh had mentioned, to get things going. So the team will be working hard out of that ESOC.
And we have a lot of folks here from overseas. In fact, during our pre-launch press briefing, we heard from Cesar Garcia, who told us that there were 800 people that had come over from Europe to be here to not only work this launch. Certainly we've got many of them here in our own control room, which you're looking at right now as they are in the front row of the Mission Director Center, but also throughout the Space Center, both as just to witness the launch, to also support it in many ways. And we also just heard an eruption of applause. Take a look there.
Yeah, we see them applauding in the Mission Director Center. Haven't heard what that's for yet, but again, we're assuming that's phase 2 of the solar array deployment. So there's several milestones that have to occur for that to happen. So we'll hopefully hear that soon from Cesar Garcia, and things will be moving forward. So I'm hearing now from Cesar that solar arrays are confirmed deployed and they are power positive. That's a good news. So that's why they were celebrating, Daryl.
Yeah, that's right.
Very, very good thing for the mission tonight.
That's
Go
right.
Solar Orbiter.
And he certainly sounds excited on the nets when he just made that announcement. And in fact, we're going to talk to him in just a few minutes when Cesar Garcia makes his way over here to the broadcast booth. That was a pretty excited report that he just gave, and got a congratulations from the team at NASA, your team, Launch Services Program.
Absolutely. As you see them there in the MDC, they are celebrating. They deserve it. It's been a lot of years. Some of these folks, 7 to 8 years spent on Solar Orbiter, and they're very happy for this tonight. So that's a huge thing, and they'll get started. They're happy, but they will get going in the ESOC and start checking things out. So very happy for the Solar Orbiter team and the successful mission tonight. We always love this one, and as you heard from Omar earlier, this is just the beginning for us at Launch Services Program. We've got Mars 2020 coming up next, which is another Atlas V with a few more solids than we had tonight, but things are going great for Solar Orbiter. So Daryl, I'd like to say thanks for having me on the show tonight. It's been a pleasure working with you and following this mission. As usual, you did a great job, and thanks for having me.
Well, likewise, Mick, we appreciate your expertise. Thank you for saying that. You have been a wealth of knowledge during this entire mission, and it's always nice to have somebody who knows the rocket, knows it well. And you've not only were giving us good insight into the flight today, but also on-the-fly calculations for
Appreciate
standard
that.
to metric. That was
Appreciate
something to behold. Watching you peck away at your calculator to get those for us and then scribbling them down, just the old-fashioned way.
Thank
All
you.
right. Well, that's going to wrap it for us for the moment here at the Mission Directors Center. We're going to send it back to Joshua and Tim Dunn.
Thanks, Daryl. Yes, I am with Tim Dunn again, and now we can say we did it.
We did it.
We did it.
We can say
you all
that.
did it.
Absolutely.
So I'm just here getting to share the good news, but you guys are doing the hard work. So Tim, congrats again to you and your team, and the ULA team and everybody else here at ESA, and just a phenomenal effort.
Excellent. No, I just got off the net with our spacecraft mission director, Cesar Garcia, and as you can imagine, he gave me the final 2 milestones that the solar arrays were completely deployed, as well as the spacecraft acquiring the sun, the solar arrays acquiring the sun, and power positive, meaning generating good power on the vehicle. Vehicle's healthy, completely healthy.
Awesome.
And on its way to the sun now.
Awesome.
Really good news. now I can celebrate.
There you go. Awesome. Do you all celebrate collectively, or do you just go home and take a nap? Is that celebration for you guys?
I think given the hour of day, we'll probably celebrate a little bit tonight, go home. We've got a few celebrations planned for tomorrow during the day.
Good.
Yes.
Yeah, so practically speaking, on kind of the business side of things, what happens for LSP after a launch? Are you all just, you're done and you kind of, you're done? Or is there more work to do for Solar Orbiter?
Well, for Solar Orbiter, we obviously have to review all of the data from the rocket. So that's a process that takes on the order of a few weeks, maybe a month, month and a half, because what we want to do is we want to look at every piece, every parameter, every little bit of data that happened tonight and in flight, during the countdown in flight, analyze it, see if there's anything that the data is telling us. We're all a bunch of engineers. We want to scrutinize the data and then apply that and look at that. If we see something a little funny, address it before we have our next launch. And certainly if we, the LSP team, find something in data, we would obviously share that with United Launch Alliance. And likewise, they provide us a lot of very detailed data. So getting ready for Mars 2020, you spoke to Omar just a bit ago.
Yes.
We're going to be really excited about flying on this magnificent
Another
rocket
Atlas.
one more time this year. So there's the Atlas V is just incredible. We love flying on it. The United Launch Alliance team is amazing. I would like to say the Launch Services Program team, my team, it's incredible. Thank you for all of your dedication for many years to make what happened happen tonight, working right alongside United Launch Alliance and your colleagues there. And then we all worked alongside our colleagues here at the Eastern Range with the 45th Space Wing. And then I can't end my comments without thanking our spacecraft customer.
Yes.
And in this case, it's the European Space Agency with their Airbus contractor who built the spacecraft.
Yes.
Just a joy to work with those guys. An international collaboration, 10-plus years in the making. I know you guys have been talking about that all night, but a lot of challenges. But I tell you what, when a team is focused on mission success, that's the universal language that we all speak. And here we are able to celebrate that.
Yeah, and I wish we could somehow share something more specific with people to kind of let them understand